Hey, everybody, welcome. I'm Marty Hurst, Interim Dean of the School of Information. Before I introduce our awesome speaker, I have to make the following announcement. This event is being live streamed and recorded and may be posted on the web. If you ask any questions or make comments, they may be included in the live stream and recording. All right. So it's my great pleasure to introduce Emeritus Professor Dan Weld, who is the director of the Semantic Scholar project at the Allen Institute for AI. Dan is a close colleague of mine. We work together on a lot of projects. He also he's wonderful at running a complex research project that really makes things happen in the world. He's also an amazing advisor who has a whole large number of fantastic PhD students who are out in the world doing great things, including being professors at top universities. So I always learn something new every time I talk with Dan, and I think he's especially appropriate for this group here at the iSchool and those of you in HCI and computer science, because he's really been studying the intersection of AI and HCI for many, many years. So he knows a lot more than most people about this topic. So we're very excited to have him here. Please join me in giving Dan a warm welcome.
Thank you so much. Thanks, Marty. Really nice introduction, and also it's been super fun learning from you and collaborating with you. So mutual admiration society here. Let's see, I'm going to wrap this talk in a couple of different ways. One way is sort of a personal history way, talking about my transition from the University of Washington to AI2 with its mission for the common good, and specifically the Semantic Scholar project that's working to try to amplify the speed of scientific research. University of Washington's fantastic, but after many years there, I became a little bit tired of writing yet another paper and wanted to try to actually get systems out there used in the real world. Facebook and Amazon and the other big tech companies seem to be doing just fine without me. So having some sort of common good mission was really exciting to me. So I'll start out with the UW side and talk about intelligence augmentation, which is another way of thinking about how do we get humans and AI systems interacting together so that they can do more than either one of them can do alone. And started working on this problem quite a long time ago at the university, way before large language models came around. But it became clear even there that there's a danger if we don't know how to control our AI systems better, then they're going to end up controlling us, which didn't seem like a good thing. Along the way, I did a sabbatical at Microsoft Research and wrote a paper I'm still really happy with, trying to point out guidelines for human AI interaction. Recommend this to people who are interested. During the talk today, I'm going to focus on a subset of these guidelines. And in fact, I'm really going to be spending a lot of time talking about guideline 11, which is make clear why the system did what it did. This is sort of the genesis of the idea that AI systems should be able to explain themselves. I'm still trying to figure this one out. So a lot of the talk's going to be about that. Explanations have lots and lots of uses. In particular, they're very helpful for model development before you deploy an AI system to be autonomous. They're also useful in a number of ways with humans interactively for knowledge discovery and for model audits and so on. But I want to talk about decision making and in particular how explanations can be used to try to hopefully get the human AI team working better together. I'm going to start by talking about some work led by Sherry Wu, now professor at Carnegie Mellon, and Gagan Benzal, who is at Microsoft Research. And we try to take a really simple model of a human AI team. Specifically, imagine that some sort of problem comes in and the AI system looks at it, makes a recommendation, then the human looks at that, and they have the final say, and they make the final decision. And maybe the AI explains itself, maybe it doesn't. So what we'd like to do is have these teams, do better than either one could do alone. It's a simple model, but I think it actually captures the essence of lots of different things that we see in the world where AI is being applied. For example, clinical decision making in the judiciary, and as I'll be talking a lot about today, in scientific research. When we started doing the work, people said, why are you even studying this problem? It's been clearly shown that explanations are helpful. Some of the papers just showed that people like explanations, but there were a number of papers out there that showed it's not just liking, it's actually the team performance goes up. And so here are a couple that have been published before we did our work, showing, you can see in that column, the team performance is well above the AI performance. The problem is, if you look at these a little bit more carefully, oftentimes buried in the details. In fact, in all of these cases, the AI system did better than the human, and the AI system did better than the team. And that's kind of troubling, because why do we want to have a human involved at all in these situations? What we would like to do is come up with complementary performance where the human and the AI can work together to do better. Otherwise, pure automation might be the best solution. Okay, so here is the question. Can we come up with a human AI team that does better than the human alone or the AI alone? And in particular, do explanations help in this context, raising things even higher than you would have without the explanations? Okay, what's the intuition? The intuition is that explanations should foster appropriate reliance. So help the system, help the human decide when to trust the AI, and also expose the AI's errors so that when the AI is making a mistake, the human's able to recognize that more clearly. It really seems like this should happen. But to actually see whether it happened, we studied 3 really simple domains. 2 were text classification domain. The last one was LSAT problems. And in particular, looked at a bunch of different conditions. So one is the solo human. The other one is the AI making a recommendation showing its confidence. There's also the AI generating an explanation using what was at the time a state-of-the-art system called LIME. There was also, because a number of papers had the AI explaining the top 2 answers. We tried that as well. And then we had a cool idea called adaptive explanations that I was really sure was going to be the best of all of these. So like secretly, we were hoping that the adaptive explanations were going to do great. Okay, so our explanations helpful. Yes, they are helpful. So that's good. But of course, there has to be a but, or I wouldn't be talking like this. So the but is that if you look at the different explanations, some of them are helpful more. Look, the adaptive one seems to be doing slightly better. That's great. The problem is that actually no explanations at all, just the recommendation and a confidence did the best of all of these. So the explanations aren't really adding any extra value. This was really, really troubling to me, and we thought maybe there was a mistake. So we did the experiment again, and we did the experiment again, and we kept getting the same results. So that's too bad. So at least the question, like, why is this happening? And the conclusion we came to was the AI systems are creating reliance, complete total reliance, not appropriate reliance. So they're causing the human to trust the AI, but not to learn when the AI is trustworthy. To understand this a little bit better, we did another experiment, which is similar. This is one of the times we repeated it, but we were worried maybe the problem with the explanations is that the explanation technology, Lime is terrible, and we really need Lime++ or some other better explanation system. So we added a new condition here where the AI gave out human explanation. So we hired people to generate explanations for both right answers and wrong answers that were really good because humans wrote them. And then when the AI made a mistake, we gave the explanation for the wrong answer. And if it got it right, we gave an explanation for the right answer. And I'm going to present the data in a slightly different way. So rather than take the average of all the points, I've stratified things so that I'm showing you how well the team does, or in this case, the human is acting by themselves on the cases where the AI is right and when the AI is wrong. So here, the human is not hearing anything about the AI. And kind of interesting, actually, they're doing better on the problems that the AI gets wrong, which is kind of interesting. Okay, cool. So now suppose that the AI provides a recommendation. In this situation, things sort of flip, and now people are getting the answer right more when the AI is right, and when the AI is wrong, they're being convinced to like switch their vote, and they're being less accurate. And if we also show the confidence, that separation gets even bigger. And if we show the Lime explanations, it gets even bigger. So notice that these explanations are becoming more and more convincing and causing people to trust the AI even when it's wrong. And when we put in the human explanations, it gets even worse still. So that's a super interesting. So it really seems as if explanations are fostering reliance, but oftentimes, at least in the 3 domains that we looked at, they aren't creating appropriate reliance. I should just caveat here, this is for these domains, is not to say that explanations can't be helpful. I think that they can in some cases, but in many cases, they just create total reliance. So our conjecture came that actually AI explanations should aid in coming up with complementary performance in this decision-making task if they allow the human to verify the AI's recommendation, verify the correctness of the AI's recommendation. This is a little bit analogous to NP-complete problems, where maybe it takes some exponential search or an AI system to come up with the answer, but then ideally you can sort of in polynomial time or linear time or constant time very quickly verify the correctness of the answer. In a situation like that, maybe explanations can help because they help the human verify the answer. Now would be the perfect time for me to show you an experiment where we show that this conjecture is true, but we haven't done that experiment yet. I've got some great ideas about how to do an experiment, so I'd love to talk to you about it. Unfortunately, Raymond, who I love dearly, doesn't want to do them, so we haven't done them yet. But the explanation does have some explanatory power in the sense that I can show you some interesting results from the literature that this conjecture explains. So in particular, I want to show you 2 textual domains. In both cases, we're going to use the same explanation type, which is where the AI system highlights the salient text that it thinks is important for the decision. And what prior researchers have found is that the explanation helps in one of these domains and it hurts in the other domain. So what's the difference? So first, let me show you factoid question answering from a trusted source. So imagine that we're asking simple objective questions like where was Albert Einstein born? And the answers have to be taken from someplace in Wikipedia, a trusted resource. Explanation type is highlight the salient passage. The AI predicts, says, I think that Einstein was born in Ulm, Germany. And here it highlights salient text. You just look at that and it's like, yeah, I trust there's no misinformation on Wikipedia, and that's where I'm convinced. Don't even need to read the rest of the article. Okay, So here's a very, very similar example. It's sentiment analysis. So is this movie positive or negative? In this case, the AI predicts it's a positive review. And again, the explanation type is to highlight a salient passage. So there it is. Well, special effects wowed me and I was stunned. I was transported to a different world. Sure seems like a positive review. The problem is, if you take the time to read through the rest of the review, actually there's information that tells you, no, it's not a positive review at all. So the explanation is not helping you. You really have to do the whole task yourself. And in particular, the explanation doesn't let you verify the situation. Okay, so what are the lessons from this? Explanations increase trust in AI, but not necessarily appropriate trust. They help if they really help the human decision maker verify the answer. And the problem was that we thought about more and more domains. It seemed like there were very few domains where an explanation actually helps you do that. Let alone could an AI system generate an explanation like that. So that was kind of troubling. And there's a meta lesson here too. First of all, not to trust my intuitions about human AI interaction, but actually test things. Also, test them on the real task I really care about, not on some proxy task. And I became really, very skeptical of Mechanical Turk, in particular, where you're paying people. Suppose that you really care about this problem, what would you do and would explanations help? Wanted to look at real humans doing real tasks. This is part of what brought me to Semantic Scholar. Yeah.
Thank you so much. This is so cool. How much did you find that the prompt you gave the AI impacted its results? Because for like the Einstein question, it's kind of open-ended, right? Like where was Einstein born? Versus the sentiment analysis question, was it framed as like positive or negative?
Yeah, the two tasks are different. In one, it's a generative task where it's pulling, creating text that answers the question. The other one's a binary classification task, and they were, the AI systems were trained separately using different algorithms in both of those cases. I think the type of explanation is really a little bit independent of the AI algorithm going on. Lots of people have made the case that an explanation is useful if it exposes the AI's reasoning process. And I'm actually arguing for decision-making, no, that's not important. It doesn't have to expose the AI's process. It just has to help the human verify. Yeah.
We apply AI to education, tutoring systems. Often we don't want to give the answer away. We want to give hints. Have you studied the setting where you don't present the decision? You only present explanations?
So again, I think there's lots of things. So that's kind of like a knowledge discovery task as opposed to a decision-making task.
So you leave
different
the decision up
to,
you leave the stating a decision entirely up to the person and present potential explanations without present.
I haven't studied that, but there have been a number of papers that have looked at that, and a number of papers that try not to have the AI present its explanation, but give different types of explanation. Sometimes they bias the explanation based on what they think the answer is right. So they give an unconvincing answer in one direction and a convincing answer in another direction, called the sort of coercive explanations. There's a bunch of other work like this. And I think that there's still quite a bit of stuff to do. Yeah.
So I guess this is a relatively early stage work, but I was at least the last bit of experimentation is early stage. I was wondering if you have any intuitions on whether the same kind of lessons may apply to a scenario where it's AI plus AI. So there's all this work around chain of thought and tree of thought and other mechanisms to provide the LLM's reasoning to the LLM to help the LLM make a decision whether it's right or wrong, or what eventual decision needs to be made.
Yeah, I think that's super interesting. I think that area is really open to debate, and there's actually some papers published just very recently showing that kind of meta reasoning where one AI is debugging another AI actually doesn't help at all. It probably, maybe it does in some cases, and maybe it does with some kinds of AI, but I think we're still trying to figure that one out. Other questions? Awesome. Okay, so continuing my journey. So this brought me to Semantic Scholar. What is Semantic Scholar? It's motivated by lots of problems in society, climate change, pandemics, and so on. I think we've got a host of societal problems where scientific advances can really make a huge difference. And there's a problem, and that's information overload. So over 5 million papers published last year. It's about 5% growth, so doubling about every 11 to 12 years. And siloing, where people who try to keep up with what they're doing oftentimes get very narrow perspectives. Whereas, science of science has shown that, in fact, when you can take disparate ideas from two different fields and put them together in appropriate ways, that actually leads to the biggest advances. So there's a question: can we, build an AI system that helps scientists do things better? One way of thinking about that is like a co-pilot for scientific researchers, or trying to build an automated research assistant. That's what we're trying to do. It's a really cool project. It's been going on. Actually, our 8th birthday is next week. And there's a lot of people on the team, spanning from software engineers, people on call keeping the system up, graphic designers, business development that's negotiating with publishers to get us the content, and on, obviously a research team as well. Especially exciting to me is 8 million monthly active users. This makes it a really cool test bed for human AI interaction. Underlying everything is a lot of data processing algorithms. We pull data from 30 different sources, have 25 machine learning models in production running on all of this stuff, have built up 215 million paper scientific index. So our algorithms have to be very scalable so we can run them everywhere. Because there's a lot of expense doing this, one of the things we do is we make all of the data available, our complete academic knowledge graph, available either through download or free API access, because we want to encourage the rest of the community to try to build these kinds of systems too. We think there's too much to be done just by us, so let's help you and other people do it. If you haven't gone there, please do and try Semantic Scholar. It's cool. I want to sort of divide the rest of the talk into what I like to call the scholar's funnel. So first, discover papers that might be interesting, then decide which ones need to read carefully versus maybe I can just skim them very quickly and file them away. Which ones I want to read in detail, and how can I do that more effectively? And finally, the last process is ideation and synthesis, coming up with new hypotheses, and so on. I'm going to start with the discover phase. You can think about, different things. Sometimes we want to discover research papers. Sometimes actually we're interested in discovering people. And we can do that using people or via papers. We've done a number of projects recently looking at different types of discovery. It's a big project, so I can't tell you about everything that we do. I'm going to tell you about 2 narrow points in the space that we've worked on for discovery. The first one is what we call our research feed or adaptive recommendations. Another way of thinking about this is it's like Spotify for research papers. So we learn what has you excited, what you're interested in, and then we try to give you a feed as we read new papers come into our corpus based on what you've rated, what you've written in the past, what you've browsed. We learn a preference model of what it is that you're interested in based on a scientific paper embedding. It's kind of cool. That's a whole nother talk. And then every week we send you an email telling you here are the things that you might be interested in. One of the people's favorite features. If you haven't signed up for them, please do. If you rate just a couple papers, we'll give you some pretty good suggestions. So for example, here's one of the emails I got actually like a couple of years ago. I was interested, especially in academic paper summarization at that time, and it recommended these two new papers for me. So that's cool. Bringing this back to explanation, in some sense, we've got this question about, is this actually really interesting to me or not? The AI is predicting this is going to be interesting to me. How did the AI system explain that to me as a user? And Hyunsu Kang, who's graduating Ph.D. at Carnegie Mellon, really awesome researcher, has done 2 internships with us, one of which resulted in this particular paper here, which came up with a new explanation type for paper relevance. And there it is, that little bit of orange that just sort of appeared at the bottom. We call it a social cue. And it basically tells you one of the authors of this paper has a particular social connection to you. For example, maybe you've cited this person before, or maybe you've got papers by this person in your library. It turns out adding these social cues caused a 33% relative increase in click-through rate, which is like a pretty big difference. And so people really seemed to like it. There's a lot more in that Kai paper besides this, but I don't have time to talk about it. At this point, you should really be saying, okay, great, people clicked on it, but maybe it was just clickbait. How do we really know that these explanations are helping the scientists verify that this is really interesting? So just because they clicked doesn't mean it really is more relevant to them. Unfortunately, we haven't done this experiment yet. I'm sort of kicking myself for not doing it, but we're in a position to do this very, very soon. So I hope to tell you more about it later. Let me just explain why I think it's true, though. So the social cues complement content-based descriptions, which come out by the title. The title itself and the abstract are part of an explanation. They say it's topically relevant, but for a paper to really be interesting and useful to me, it's got to be high quality as well. And authors on the paper are a proxy for quality, imperfect, maybe leading to biases and rich get richer effects, but it's still a cue that people seem to find useful. Yes.
Since the Semantic Scholar project has been up for a while, can you kind of use longitudinal cues to indicate if the recommendations are good? Because if they provided good recommendations, perhaps people will end up reading those papers and eventually citing them.
We can do that. We've talked about doing that, but we haven't actually done that. There's some challenges. However, I will show you an experiment that we've done recently, which is along the lines of proving this. It's proving it for a different type of explanation, though. Yep.
I have a two-part question. So you said, like, right now you're grading the sufficiency quality based on the author. Are you trying to make improvements in, like, other ways to grade the quality of the paper? Because that does seem.
Yes. Quality is a hard one. But in terms of topical relevance, I'm going to show you pretty shortly something that improves there.
And how often is the model updated? Is it updated as the publications come in, or do you do it like periodically through the year?
The model is updated. I think right now it's updated every night based on the feedback that you give during the day and that we've gotten from.
I mean, it's new publications.
And the new publications come in every day. And you can say, I want daily, recommendations, or I want weekly recommendations. And one of the things that's nice about this is you're in control, so you can give it positive and negative feedback. So when it comes, in fact, if you guys sign up for it, probably will send you a paper you don't like. If you say, no, I don't like that, that really helps the system. So the more feedback, the better you can do. Yeah.
So for the social Q metric, is that determined by like degree of connectedness to the papers that you've like rated already?
It is, there's a number of different Qs. I'll talk about that in just a second.
Thank you.
Okay, moving along. One of the things we've done this year is expand this idea from email alerts to the website. So here you can see we've color coded the authors on the paper. This is the result of doing a search on the website. See, Morella Lapata was pointed out that there's a connection there. If I click on her name, it explains what the connection is. She's authored 3 papers that I've saved to my library. Also tells me some other information about her. We're doing some experiments right now looking at different variations on this. And in particular, we've implemented 6 different Qs. So this is the way things are cited. To be my personal intuition is that authored papers you cited and authored papers with you are probably the most important Qs. There are also Qs that don't happen as often. So so we're still trying to figure out where the benefit is coming from, if there's any benefit at all. This is an active experiment. Okay. Any questions here? I'll go into the next part. So, you know, the difference between discovery and deciding is a little bit nebulous. I'm not sure if I should make that distinction, but here's a different set of research that we've been doing that are sort of largely focused around deciding. And I'm going to categorize it in 2 different directions. One is it a personalized technique to help somebody? So we'll give different things to different people, or is it one size fits all, which can be thought of as a pejorative, but actually I think we can deliver you know, these aids quite usefully, even if they're not personalized. Done a bunch of different systems, and I'll tell you about a small number of them. So the first one is done by Isabel Casciola during a gap year she spent with us at Semantic Scholar. She's now a graduate student at Johns Hopkins doing really cool stuff. And what she did was build a summarization system, which is, again, a whole talk about exactly how this works and how we can run it really quickly so we can run it over millions and millions of papers. But we generate these TLDRs, which are designed to look like what somebody might tweet about a paper. And actually, they're very, very different from abstracts. But you'll have to take my word for that. I want to talk about, you know, are these actually explanations useful to people? And we did an evaluation of this, which was problematic. And part of the reason it's problematic is like, we're looking at this. So what are the metrics? The natural metrics we thought about are things like time on page and click-through rate. And the problem is, should we be hoping that TLDRs increase the time on a page or decrease the time on a page? We couldn't figure that out. And if you can't figure out which of those is the right thing, then, you know, statistical significance one way or the other doesn't really help you. Typically, of course, websites want to keep people on the page more, so that should be good. But actually, we want to make people more efficient, so whatever. The users said they liked it in qualitative feedback, so we shipped it. But then very recently, we got around to adding it into the email alerts, and we realized this is actually an opportunity to do the experiment that we didn't do and couldn't do because we finished the A/B test. So we did the experiment on the email alerts, and what we were expecting was an increase in clicks and saves, and hoping that it wouldn't actually cause people to quit taking these alerts. And so the good news is, indeed, there was no increase in the unsubscribe rate. That's kind of a low bar. But unfortunately, there was a statistically significant decrease in the click-through rate. And that was really troubling to me. Yes.
is it troubling though? Because maybe it's that they realize sooner that the paper is irrelevant to them, so they can save some
Thank
time.
you for saying that.
I like TLDRs.
I will pay you later. No, the question is, why are we getting the decrease? And there's a couple possible answers. One is people are less engaged and not really paying attention. The other one is we're helping them sort through those papers with greater efficiency. And Danny did a really nice analysis by looking at the click-through rate conditioned on the action the user took afterwards. Because in some cases, when people click through the website, then they save the paper to their library. In other cases, they click through and then they decide paper's not that interesting. I'm not going to save it to my library. Of course, there may be some papers that are interesting that they don't save anyway, but we wanted to look at these two different ways. Yeah.
If there's a paper for that, I'd love to see it. It's kind of a sketchy conditional comparison to make.
It is, there's a Medium post, I can point you to it. So if you condition on saving to the library, the click-through rates look exactly the same. If you look at the papers that the user eventually decides are not so interesting, in fact, people are clicking through on these irrelevant papers much less, which is pretty cool. Convinces us that the TLDRs really are helping. And that's a one-size-fits-all approach, the TLDRs. Yunju Lee, great intern who was with us this past summer, been working on something called Paper Weaver, which tries to take the next step and make these things personalized. And here the basic idea is we're recommending a paper teaching smaller language models to blah, blah, blah. And there's a TLDR. And what she did was generate a personalized recommendation by looking at a paper that we believed you were already familiar with, maybe one you'd written yourself or something you'd saved to your library, and then generating some text explaining the difference between the new paper and the paper you already knew about, using a generative large language model. And you can also go through and choose and say, actually compare it to a different paper in my library, and so on. There's a lot of detail here, but moving along, they did a pretty small scale study that showed that participants thought that they were able to make better decisions about relevance and triage, but we haven't yet shown that these are really helping. But I still think it's kind of cool and an important thing for us to push on some more. The last thing I want to talk about in sort of the decide category is something called expandable summaries, done by my Ph.D. Raymond Fox with Joseph Chang, Amy Zhang, and Tal August. And the basic idea is we want to allow people to ask questions about a paper and do it in a really easy way, and also do it in a way which allows verification of the answer, because these language models don't always tell the truth. So let's see if I can go here. One thing we've done is for all the VLDB papers, we generated these explanations, so it's not been rolled out into wide-scale production. I can pick one of these papers, like ACTA. Spatial platforms have become increasingly important in people's daily lives. Does anybody know what a spatial platform is? I don't know what a spatial platform is, so I can just click on that, and it uses a language model to calculate what is the most likely question to ask, as well as giving 3 default questions: define, expand, and why. Actually, I don't care. I want to define what the heck these things are. Okay, spatial crowdsourcing services like Uber, Lyft, and DiDi. Okay, so that's what these spatial platforms are. I can read through the rest of the abstract, probably faster than you because I've seen the paper before. how does the revenue estimation model work? It generates an answer here. I can click, actually, in addition to the things that are underlined, you can drag out any span and it will generate what it thinks are the interesting questions to ask about that. And you can do it recursively. Yeah, so I don't know, I'll take a risk here. What the heck is? Yeah, okay. What? So, and it expands it out. And out here, the other thing one can do is, because these answers aren't always right, is you can click on this little quote mark, and what the system does is it pulls up the section of the paper that has the answer, and if that's not good enough, what you can do is you can start reading the paper, and we just throw you into a reading experience where we've highlighted in blue what the section of the paper is, and you can read that, or you can, read any part of the paper you want. So here it started me right out in section 5. So we think, although we haven't really shown yet, that these are going to be really helpful in people assessing the validity of the explanations. Okay, that's another example. Sorry, up here. Yeah.
I was trying about this looking at papers that I co-authored. Seems to be doing a pretty good job. In terms of maybe popping up a level, you talked about a number of individual projects, and all of them individually seem useful. Is there kind of a design philosophy for all of Semantic Scholar in what, like you don't want to get to the point where you get to feature bloat, right? You get too many things being thrown at users and it becomes overwhelming. So how do you think about this, especially as an organization that's also trying to do research and publish results, and while also building a product that people are trying to use? How do you make those trade-offs, and how do you cull projects that are perhaps not going as well as you hoped, or find better versions of those projects later on, right? Like how do you make those decisions?
Yeah, that's a great question. And I don't really have a perfect or even very good answer. Historically, we've been pretty bad at taking features out of the project, especially ones that I really liked, even if, because I really like it. And it takes effort to take them out too. So I don't think we've got a good answer. Another question is, how do we trade off the quality of the product that we're making versus the research we're doing? So there's two models. One model is the research team at Semantic Scholar is like the advanced development team coming up with new features to put into the product. The other model is the product team is building a platform that allows the research team to do really cool, influential research. And I'm afraid I haven't really figured out which of those views is the right one. So we're sort of muddling along halfway in between. Finally, I just want to say it's an incredible privilege being at AI2 and having a nonprofit mission. But it's also a challenge because it means we have to decide what our mission is and how we should judge whether we're being successful. If I was at Amazon, be very, very clear, like how much money am I bringing in, and but we don't have that to guide us, and so we're trying to figure out. Another question is like, which users are we helping? We have 8 million monthly active users. That's a lot. Most of them are very, very casual users, and so we have chosen, because our mission is to accelerate scientific progress, to focus on the users that we believe are actively moving science forward, as opposed to policymakers or lay people trying to understand science. And so we basically have some classification rules to figure out whether somebody is what we call an active author. We don't do anything differently for them, but those are the people that we focus our metrics on to see whether or not we're increasing how often they come to visit us, for example.
Question from online. Someone was concerned about the results of a query they did on Semantic Scholar where they felt it brought up probably a dubious publication. And so they asked, is there any feedback mechanisms in Semantic Scholar to enable users to flag dubious results?
There is, and one thing that's kind of cool is we have a customer support team. So one is there's a feedback button, I believe it's on the bottom of the page. And so you can do that and it will send the page and we'll have somebody look at it. That said, we get a lot of feedback. And so for isolated errors on individual papers, we can't always fix it, I'm sad to say, but we will at least get back to you. Yep.
These are super cool features. From my understanding, a lot of them right now are focused towards papers in computer science.
Yeah, that's a great question. So Semantic Scholar covers all fields of science, but we prioritize computer science and biomedicine. And to be honest, we prioritize computer science the most. So we tend to bring out new features just in computer science. And if they're good, we roll them out in other areas. It also gets back to the mission. So if we're trying to do new research and we can show that it works on computer science, then we sort of satisfied the research component. And there's always this question, should we spend that time and energy to expand that feature out to everything, or should we move on to the next feature? It's a case-by-case basis. How am I doing on time?
We have the room till 1:30. Usually people wrap up at the hour. Some people have to leave at 1, and then we have.
Gotcha. Okay.
But you've been answering a lot of questions.
Well, so I will, really cool system. I'm going to tell you how it works. I'm not going to tell you how to study. I'm going to move on to talking about the last thing, which is the reading process. In some sense, reading is not that important because we don't read that many papers. In other cases, you can view reading as like incredibly important because it takes so long to read a paper. It's really, really hard. And in studies actually that Marty did, she found that researchers moved back and forward within a document, looking for definitions, checking citations, breaking their flow. And that raised the question, can we build an AI system that helps by putting AI right in the reading process? We have done quite a bit of work in this area. Building on Marty's suggestions, I'm going to only tell you about a couple things, starting out with the Scholarify system, which was her idea, and then talking about a few of the more recent systems. So Scholarify is the work of Andrew Head, who did got his PhD here and did a postdoc with us at UW, and really was led, I think, by Marty with fantastic vision. I'm not gonna. There's actually a lot of things even within Scholarify, so I'm only going to talk about one or two things. One is the ability to do definitions of symbols and terms in the paper. So here we're on page whatever we're on, and I can't remember what K is. Rather than thumb all around and try to find K, one can just click on K and Scholarify pulls up the definition. It also de-emphasizes by dimming the text, all the text which doesn't seem to be relevant to K, to make it easier for you to look for other passages. Another thing that Andrew implemented, which was super cool but not scalable, are equation diagrams where you can click on various symbols and actually understand graphically what's going on in the complete equation. This system, published at CHI, really seemed to be exciting and successful, and we decided to move it into production. The symbol definitions seem to be hard, and so we actually started with one sort of initial feature, citation cards, which seemed a lot easier. So here, if you click on a citation, instead of bring you all the way to the bibliography at the back of the paper. We just pop up a little window giving you the details, giving you a TLDR for the paper, allowing you, in this case, it's in my library, but if not, I can add it to my reading list by just clicking that button. There's not really a whole lot of AI here, but there's actually a lot going on with citations. So another system that Joseph Chang implemented is called CiteSee, published at CHI, honorable mention last year. It tries to help you contextualize these citations in a personalized way. Specifically, it color codes the citations based on their relationship to you. For example, the little heart sign, maybe you wrote this paper or you've cited it previously. And for other new papers that you haven't seen, color coding them based on how relevant we think they're likely to be to you. The CiteSee system did other cool stuff. It tracked how far you read in papers. So it could remind you, wow, you read 83% of this paper. Actually, you did it 11 minutes ago. So why you should have remembered that. CiteSee is in production now, which is kind of cool. So you can play with it. The final thing I want to talk about is the semantic skimmer, also collaboration with Marty, done again by Raymond. And the point is, oftentimes we're reading a paper and we are reading like the first time, we just want to get a gist of the paper. We don't want to understand all details, at least at this point. Can we build features to do that? So Skim, which was published at IUI last year, has lots of cool features, but rather than talk about it, and rather than talk about the results, let me just show it to you. Here I am in Semantic Scholar. I can find paper. I want to show you some other things in here as well. Down here with this little bar at the bottom, that's sort of an under construction part of the site. You can see topics. We automatically extract what we think are interesting and relevant topics from this paper. You can click on it and we use a language model to generate a description. We provide attribution because we tell you that that description was generated from this particular paper. And give you the context there so you can verify the definition is right. You can click on other things like NLI. In addition, we can generate other papers where there's seminal papers or recent papers that might be interesting. It's kind of cool. We have is this a good description for the topic? Yes or no? Of course, most people don't give us feedback, but of the feedback we've gotten so far, 97% has said it's a good description, which for these language models, we think is pretty awesome. Back to Accord, we can open the paper in the semantic reader. And let's see, first of all, let me just click there. Things are slow. They seem to be kind of broken. Everything's frozen. Oh, isn't that terrible? Okay. Hopefully. Man, something's going wrong here. This is a terrible moment right at the end of the talk.
It works, I promise.
Well, it worked for me before too. But it's frozen right now. Oh my God, that is so awful.
It's working for me. It's just not on your, maybe the internet there's stuff.
I blame it on the web.
I mean, it's working for me on my computer. Share my screen if you want.
Okay, I'm gonna forget about the features that aren't working for some reason and go over to that upper button there for skimming highlights. I can turn these on. Let's enable skimming. Marty, I think, is not convinced about skimming. So So we don't have it on for everybody, but you can turn it on if you like it. And we color code the salient portions of the text that we think are interesting, and also have a sidebar here where you can read with sort of like the Reader's Digest condensed version of the paper. Some of the user study people really seem to like to do that. As we scroll through this version, scrolling's not working. Okay, yeah.
I can share my
This
screen.
is really embarrassing. You guys can all play with this because it's in production now. There's a set of controls so that people with low vision can set the highlighting color differently. You can turn on and off different types of flags. Maybe you don't care about methods, you're just interested in objectives and goals. And there's a set of other controls designed to make it useful with screen readers. It's cool. Let us know whether you like it.
Is this on for all of the papers?
Sorry, it is it's running on 500,000 papers. It's right now restricted to computer science archive papers. We actually have it running over all the papers in our corpus, but the results are not super good on the non-computer science papers, largely because our PDF processing pipeline isn't working as robustly, and you get errors cascading from the PDF processing, onwards. So that's something we want to keep pushing on. I think the other thing we want to push on is increasing the quality of these highlights. I think we need to do another iteration of the model to make them really, really good. And then we'll probably turn it on by default for everybody. Okay, in summary, explanations I think are suspect, and you should look at them with questions in your eyes. They produce reliance, but not necessarily appropriate reliance. Explanations that help the user verify the answer to the problem, whether it's relevance in the case of Semantic Scholar or question answering, seem to be helpful. In paper discovery, I talked about social cues as one kind of reliance. In paper triage, I like to TLDRs and one-click questions that allow you to get a large language model to answer what you're interested in directly, along with attribution to do that answer verification. And then in paper reading, there's no explanations and no verification there, but I think it's cool. So I couldn't resist showing it to you anyway. That's it. Sorry for going long. Thanks.
Some people might have to leave, but we have 20 minutes for questions for those who can stay.
Hi, thank you, Dan, for talk. I think it's certainly interesting, the idea of the Semantic Scholar to support you in scientific discovery, but when it comes to scientific discovery, I've noticed, or I'm not sure if you have seen some of the models, but so there's a component of it that's kind of involves getting inspired by some tangential idea that's not really related to what you as a researcher are looking up, but also serve as almost like an inspiration to help you come up with new models. So for example, if you work in a lot of stuff from computer science takes a lot of ideas from psychology, especially in components of reinforcement learning, and those are the most innovative ideas that kind of foster that. So I was just wondering, have you guys, I guess not really have you guys, but how have you guys thought about possibly pursuing or pushing these ideas, especially with language models, that they can kind of connect the dots between one point to another point as well?
Thanks. That's a fantastic question. One way of asking that question is saying, hey, Dan, you have this cool scholar thing and funnel thing at the beginning of the talk, and it had ideation and synthesis, and I never saw anything more about that in the rest of your talk. What gives? And to that, I would say you caught me. I'm sorry. It's not that we haven't done research in this area, it's that I couldn't fit it into the talk. It is an area that we want to work in more. One of the things that we've done, just two of the projects in a sentence each. One is automatically extracting sort of key results and future challenges and limitations from papers and an attempt to match those up so that we can see when result from one paper might be applicable to a limitation in another. Another thing is in author recommendation, where we have a really interesting technique that's designed to break people out of filter bubbles and connect them with people that they might not otherwise talk to. In particular, people who are working on the same problem but using different methods. Oftentimes those go to different conferences and might not talk to each other, or people who work on very, very different problems in different fields but use similar methods. They might be interested in talking to each other, or you might be interested in reading their paper. So we have a system called Bridger, which is an online demo. It's not incorporated in the main site, but it's a working demo that does that. And I think that there's much more to be done, but I didn't really have time to talk about that. Sorry. Any other questions? Yes.
I have a question, I guess, that kind of relates to that one. That you're talking about these issues about discovery at this point at the bottom of the triangle on ADHD. But I don't see an argument how it almost impacts the top, and just in terms of what kind of data you're able to reason over, where you're focusing here explicitly on science, and within that explicitly on computer science, when there could be lots of value in expanding that to the social sciences and humanities in a way that can draw out those connections at the ideation synthesis phase. And so the kind of problems that you would need to address for books in the humanities or in articles in the social sciences are going to be very different from the ones that you would need to address in the context of computer science. And so I'm just curious if there's any room for expanding AI to and Semantic Scholar in particular beyond the sciences. And maybe the answer is no, you have a very narrow focus, but have you ever given thought to that, to expanding?
We have, and in fact, there's some really nice work. Again, I think that Marty's involved in, again, is not expanding to the social science. There's a couple different ways of answering your question that may pop up. One is, are we interested in social sciences and things like that? Another one is, what are the class of users are we interested in? Are we interested in practitioners in those fields, or are we interested in more lay people? Marty and working with Tal August, now a postdoc with us, built a really cool system called Paper Plane, which is designed to take biomedical papers and make them accessible to lay people who maybe some chronic disease, and they're looking at the literature and trying to figure out whether it's relevant to them. I think that's a super interesting thing. Looking at policymakers who are trying to make sense of science and figure out what they should do with respect to funding levels, you can make a really strong argument that we should be focusing on those people as well. Just read a cool Science of Science paper today, which argued, in fact, the funding levels for different areas, to different parts of science, are basically a function of how much funding was given to them last year, not what the relevant impact is on society's problems. So that seems bad. So maybe we could help with that. Of course, society as a whole is questioning science, and so doing something to try to make it easier for people to understand what's going on in literature has potential benefits for reducing political polarization or other things. There's so many directions to go, and yes, we do have discussions about it, but all those discussions so far have led with, we can't do it all, so let's keep with this focus. Yeah.
Thank you for sharing all that great work. I've been thinking a lot about, well, first of all, reading papers is really hard, and especially hard for students. And there are these techniques that people have come up with to sort of guide students that I for instance, use in class. Some of it is like the guiding someone through which parts to look at first, and some of it is thinking about certain questions when you look at a paper, like what is this about, what is the method. I'm wondering whether you've thought about more interactive ways, or like leaning more on the educational side when you're guiding someone through scientific literature.
I think that's a great question, and it's yet another population that we haven't really looked at. But I think large language models might be very effective there. Certainly language models have been shown to do a pretty good job doing basically simulating scientific reviewers of papers. So I think one could probably expand that work to help come up with sort of key questions that people might ask. I think we're going to have some problems, and I worry about over-reliance, especially in the case of students. But I think that's another really interesting direction to go. I think you had to hit it.
It's gonna build on Neil's question. Like, I'd be curious what you would recommend an advisor do for their first year PhD student. If you were like, you have this tool, and rather than coaching you to read in the way that we've all learned to read, you've got a tool that can speed you up. Like, I'd love to see that experiment.
Yeah, that's a great question. I mean, I guess I don't have a good answer. The one thing I do say is, it's much more important for them to read lots of papers quickly, rather than I think it's very easy for them to like really want to understand all the details of a particular paper and spend a week on it rather than reading lots of papers. But
This is a separate question. I come out of the social sciences, and one of the things that is the most exciting is when you have like long-running disagreements between two different groups of people. Since you've raised the idea of reliance or like appropriate reliance, when does your summarization say, I don't know, or it isn't resolved, or like that science isn't settled?
That's a great question. And I think one good thing, so first of all, I think language models do a terrible job at that, but it is, increasingly become a key aspect, and a lot of evaluations are looking at that, I don't know, appropriately saying, I don't know. And I think we need to do more work on that. The other thing, I mean, it's like people also, other cases, I'm looking at one of the topic pages, our system, somebody gave bad feedback. And because our topic page on the Microsoft Academic Graph was inaccurate. And it said the Microsoft Academic Graph is exactly what it is, and it's updated regularly, because the paper that it was getting the answer from said that it was updated regularly. Of course, the paper was from 5 years ago, and since then Microsoft has shut the project down, but it didn't know that. So yeah, I mean, there's like a whole host of problems, and yeah, lots left to be done.
Yeah, just one more question. Sorry. It seems like this framework you have here is quite interesting. So your vision, it looks like, was we have this discovery part where you send out emails, and then you decide and you read it, and then you ideate. But I'm wondering, like, I feel like when you check through your emails, you get a lot of papers, and you're just like, I don't know what to pick through. I wonder if there's something. I feel like this ideation part, and I think he mentioned over here, ideation starts as early as discovery, actually. And all it takes is really just one spark sometimes to see perhaps a visual that really, like, sometimes the text and the title doesn't really tell much. Sometimes it's a visual that pops up and someone's like, whoa, that's what I really needed the whole time. And I was just curious. I don't know, I feel like there's just something at the top that feels like there's like an ideation part that's kind of should be embodied within the discovery. I don't know if you agree or disagree with that. Maybe.
I do actually have grown really tired of this diagram, and I vowed to take it out of all future talks. But I'm not quite sure what should replace it. I will say one thing. Jonathan Bragg, researcher at Semantic Scholar, built a Chrome browser plugin, which is actually pretty great. But he's, so if you like Semantic Scholar, try it. But he's extending it in a number of interesting ways, and it brings sort of the power of Semantic Scholar as you're going around the web, which I think is one sort of, it's more of the assistant vision. I think is one cool thing. Exactly how we can turn that into something that helps with ideation, I'm not so sure.
I have a question from online from JD, who says, like many others, I imagine, can't wait for these business that's making approaches to become mainstream. He wanted to know more detail about how much need finding you end up doing at AI2. And he gave a couple examples, one of which, have you explored alternative interaction modes, conversations say, or other iterative interactions, or supported the creation of, for example, mind maps or other visual sense-making approaches?
Yes, we've done some of that, and no, we haven't done all of that. I really believe the interactive model is important. And notice in the question answering system, that was very much sort of an iterative, having a dialogue about a paper, but not in a, I'm going to type out my questions. It's sort of like a one-click direction of the dialogue, which I think is exciting. Mind maps and so on, I think are also pretty cool. It's not something we've done anything with, but some of the people who use our underlying data services like Connected Papers, which is a really cool site. So if you like mind maps, you can go and check out their visualizations. I think that, again, there's like so much more to be done. And one message I'd like to leave you with is to do it all, really need everybody's help, or at least some people in the audience's help. And we make all the data available via this API. So it's actually really, really easy to build a scientific assistant tool on top of the data that we've already processed and we update. I know some people need to leave, so I won't be ashamed or offended if you do, but I will stay around.
You've been working pretty hard. So let's thank Dan for the